Solve problem 4.2. Two blocks connected by a rope. A hanging mass generates an acceleration for a second mass on a horizontal surface. One block of mass m1 equals 3 kg lies on a horizontal frictionless surface and is connected via a massless rope running over a massless pulley to another block with a mass m2 equals 1.30 kg hanging from the rope. We need to find what is the acceleration of block M1 and what is the acceleration of block M2. From the figure, we understand that block M1 can only move along the horizontal, which is the x-axis, whereas block M2 can only move along the vertical, which is along the y-axis. And M2 is causing an acceleration in M1 as it goes down. So here we have acceleration of M2 pointing down, whereas acceleration of m1 will be towards right. Both m1 and m2 will have the same magnitude of acceleration as they are connected together via a rope, and by whatever rate m2 goes down, it will pull m1 to the right with the same rate. Therefore, we write acceleration for both m1 and m2 as A. Now let's diagram the forces acting on them. We will start with m2. The first force that acts on M2 will be the force due to gravity, which is pointing vertically down. I will call this Fg2. Block M1 and M2 exert force on each other via the tension in the rope. And from Newton's third law, the magnitude of these tension forces has to be equal. So we show the tension of M2 directed towards the suspension point. I will call this force T. Then we do the same thing for M1. First, we show the force due to gravity acting vertically down. We call this Fg1. Then we have the normal force acting perpendicular to the surface. I will call this N for normal. And then you have the tension in the rope directed to the right. I will call this T. After we show all the forces acting on mass M1 and M2, we are going to write equation of force for both of them. Let us start with M2. M2 is accelerating down, and whenever an object is accelerating, the equation of net force becomes F net equals M into A. And since this acceleration is pointing down, I have to take a negative sign for it. Now F net is the vector sum of all forces acting on M2. And when we take vector sum, we have to add all the forces acting on M2 by taking their direction into consideration. And we know by convention, any vector that goes up or to the right is taken positive, whereas any vector that goes down or to the left is taken negative. So here for M2, my tension T is pointing up, so it will be positive, whereas force due to gravity is going down, so I have to take it negative. So you get F net 2 to be equal to T minus Fg2, that is equal to minus M2 into A. The force due to gravity Fg can be written as mass times acceleration due to gravity. So we rewrite this expression as T minus m2g equals minus m2a. Move m2g to the other side. We get T equals m2g minus m2a. Let us call this equation 1. Now we do the same thing for mass m1. M1 has forces acting along two axes. We have forces acting along the x-axis as well as the y-axis. But since our acceleration is directed along the horizontal, which is the x-axis, we will only use the equation of x-axis here. Whereas along y-axis, there is no acceleration. So net force along y-axis for mass 1 will be 0. And that will give us the force due to gravity to be equal to the normal force. So let us write the net force along x-axis. F net x for mass 1 will be equal to m1 into a. Here acceleration is to the right, so we keep it positive. There is only one force acting along x-axis for mass m1, which is the tension in the string. So we write T equals m1a, and we call this equation 2. Now, if you compare equation 1 and equation 2, you will see both of them are equal to the tension T. So if the left-hand side of an equation are equal, that means the right-hand side has to be equal too. So I will write equation 1 is equal to equation 2 and write their right-hand side here. We have m2g minus m2a equals m1a. I want to find acceleration, so we will move all the terms with acceleration together. So let's move negative m2a to the other side. So we get m2g equals m2a plus m1a. m2g equals, take a as common, m2 plus m1 into a. We need to find the acceleration a, so we divide with m2 plus m1 on both sides. We get m2g over m2 plus m1. Now substitute. m2 is 1.30 times g 9.81 over m2 again 1.30 plus m1, which is 3 kilogram. And when you solve this, you get acceleration a to be equal to 2.965 meter per second squared, which you can round off to 2.97 meter per second squared. So this is the acceleration of both block M1 and M2.